So we'll create a cookie counter program with a new file, main.go, package main, and then func main, and pretty standard stuff here. I'm not going to use the session store. I'll just use the cookie directly. So we'll just write out the value of the cookie. So, rect.cookie, give it the name, just call it counter. And then if the error is http.error no cookie, or just check if it's not nil, then that means there's no cookie. So this is the first time the user gets there. And so we create a new cookie. And the name is going to be counter, and the value is going to be 0. And then for every subsequent time, we just get the count as an integer. So we use A to I and say cookie.value, and then increment it, and then write it back out again. So I to A, count, and then we just set the cookie. And print the cookie value. Yeah, let's see what that does. What did I call this? Cookie counter. Yeah, it counts. So if I wanted to clear it, I could just delete the cookie out of here, you know. And now it's back to 1 again. So
copy that code over.
Yeah. I don't think anybody did the other one, so we'll do it later. So the final thing for the project is TLS and certificates. I don't want to spend a ton of time on this, but notice in HTTP there is a listen and serve TLS. So if we go to HTTP, listen and serve TLS, so it's just like listen and serve, except it also takes these two files. So they have an example here. So you give it this cert and key, and then it will serve it securely. Okay? So he's telling you you would access it with the S instead of value. Okay? So a secure connection allows communication between the client and server to be encrypted. That means that nobody else can read it. Okay? So websites that use security like that, like a bank or something, means that they can't see your cookies, they can't see your headers, they can't see any of that. All that information is encrypted. All somebody on the outside can see is that you're communicating with the server. But they can't see any of the communication that's happening between you and the server. Okay? That is implemented using TLS. TLS is Transport Layer Security. It's the successor to SSL. Okay? And it uses sophisticated cryptography to achieve that goal that's beyond our scope. But just know that it is done, it is secure. Okay? That encryption is as good as it gets. So it's a nice thing that we have to have. If we have a login on our web page, we need to be using HTTPS. Okay? So if you have users who log into your website, you need to do that. Now, if you're a purely public site that nobody ever logs into, who cares? Because that information is not secure in any way. But if you take somebody's password, you never want to have somebody's password going over the network in plain text. We can trivially inspect those packets and see it. I showed you that with Wireshark. you could see the traffic flowing through. So you'd be able to just go in there, inspect it, and see, oh, the password was 123456, right? When it's encrypted, you would just see a bunch of gobbledygook and would have no way of being able to interpret that. So that's why we have to have certificates in TOS if we have a site that has a login, which is a lot of sites. I mean, that's like most sites. So to get a certificate is a little complicated. I'm going to show you how to generate a self-signed certificate. And that's a certificate you can just generate on your computer. And we'll see what happens when we do that. And I put the instructions in here. The Go code includes a little helper main program called generate cert, which will generate a certificate. It will generate those two files. And it will be a self-signed certificate. You can also use OpenSSL, and there are guides on the internet. If you just search for generate self-signed certificate, it'll tell you how to do it. And so let's run this and see what happens. You should be able to run this too on your computer. So I'm going to go up a folder and make a dir for TLS example and run this convoluted thing. So I'm getting the root of Go and then going to source crypto TLS generate cert. And then I'm just going to put localhost for the domain, but this should really be your domain name. So if you're google.com, your host here would be google.com. That name has got to match the cert. Otherwise the browser complains. So it wrote two files. So we see that, wrote those two files. If we look at those files, cat cert m, you'll see it looks like this. And so this is a format for the keys, but you can see it's like basically the base 64 data. And we can see more of that, but this information is used by TLS to do the encryption. So the difference here between the cert and the key, this is the secure thing. This is the thing you don't share with anybody. This is, the keys to the kingdom. And this is the public thing that people can't see. And basically the idea is that there's a relationship between these two such that you can use this cert and you can guarantee that the traffic was generated by this key without knowing this key. Okay. But you need both to run the TLS servers. So let's make that example. And we'll just copy what was in here. The example in the docs. And let's go to TLS example. And I just made a main Go. They have the same name, so I'm just not going to change anything about this. And I'm just going to run it. And so now it's listening on port 10,443. And so if I go to this URL, it should use secure. So you should use a TLS connection. Okay. See how it says your connection is not private? This is what you see when you get an invalid certificate. This certificate's invalid because it has not been signed. Certificate authority is invalid. So the process is you generate your certificates. You have to hand them to another company, which will sign them and give them back to you. And then you can use that on your domain. And that costs maybe $40 a year or something. And you have to do that. Otherwise, so you have to get it signed by a certificate authority. And there are companies out there that will do that for you. One that's free, there's a Stat SSL, I think, is free. So that's an option. They're an Israeli company that will sign your certificates for free. So it just tells you could not prove that this is what it says it is. Its security certificate is not trusted. It's funny because the communication will be encrypted. So this error is like, it's terrifying, but it's not nearly as terrifying as people think it is. So the communication is encrypted, it's just it can't guarantee who the other side of the encryption is. In other words, I said, I'm localhost, and it's like, okay, I know you said you're localhost, but nobody vouched for you. Like, nobody said that you are localhost. So I don't actually know if you are or not. And that's what the certificate authority is for, is to say, yep, he is who he says he is, okay? And so it's like this web of trust, it's the model that you use, like, the certificate authorities are granting the trust to. Anyway, It's very convoluted, and I wish we didn't have to cover this, but the sad fact is you do. You have to have these if you want to have logins on your web page. So I just say proceed, and then I can get to it. But notice you get this big red X, which you may have seen on other websites.
Have you said the start SSL is the one that signs it for free?
Yeah. I think that's it. Or stat SSL. Something like that. Start, yeah, this is it. They'll create one for you, and you can follow their instructions. They used to be only for non-commercial websites, but they have changed their terms of use, so now you can use them for commercial websites as well. So if you take money on your website, you can get one of those for free. They look a little sketchy, but it works, so it's hard to beat free. Some companies pay tens of thousands of dollars for this, so it's kind of nuts. For essentially, it's just like it's like taking your form and getting a stamp of approval. That's all it's doing. It doesn't have to get you anything. It just makes the red go away, so your users don't think terrifying things about it.
How do you know that they're for real? Like they're not doing anything with your information?
Well, the only thing you provide them is your domain name and like your name, so they can do whatever they want, you know. But as far as how do you know how they're legit is every browser comes with a list of certificate authorities they trust. And so they're in that list. I mean, that means something. Now there's also thousands of other things in that list. And this is part of the reason why some of this is kind of like, is this really that secure? Because there's thousands of these. All it would take is one to be compromised, and you know they could sell, oh yeah, you are Google, and then you're not Google. Yeah. And so, but that's how TLS works. You got to have the certificate authorities, and it just prevents man-in-the-middle attacks. It prevents people from pretending to be somebody they're not. And so, a man-in-the-middle attack is where somebody puts up a machine between you and your endpoint, so they pretend to be google.com, and so you send traffic to it, and they respond. Okay, you're like, oh, I got that from Google, right? These certificates prevent that because they can't forge the certificate. So it would come back with the red and be like, no, this person isn't who they say they are. Anyway, so we've generated a cert and we can use it, and now it's just like making a regular HTTP server. We don't have to change anything in our code. The only difference is we say this and insert TLS, and now it'll be a TLS connection instead of a regular HTTP connection. Okay? So the transport here means it's the layer underneath HTTP. Right? This is at the TCP layer. So this is above TCP but below HTTP. And that's why all the stuff above it we don't have to change. Because we're still speaking HTTP just over a TLS connection instead of a TCP connection. And just so you know, the TLS connection is on top of the TCP connection. So, but it hides all, we don't have to worry about all those details, those messy details. We just write HTTP, call this one function, and we're good. We can do both. The way we do both is just use Go, listen and serve. Give it a different port, and then nil. And now we're running both the TLS version and the regular version. Does that make sense? So we started this in another Go routine, this server, and then we started this server, this Go routine. So now we have both servers running side by side.
So then we could have different functions responding to different requests using either listen and serve TLS or listen and serve.
Yeah, so both of these are using the default server bus because they have nil passed into handler. So they would be using the same routes. You could give them different handlers and they get different routes, that'd be fine. But a pretty typical pattern is to support HTTP, plain HTTP, and then have one handler in here, and all he does is redirect to the secure version. And then users can come in either way, but the only way they can use your site is through the secure version. Does that make sense? So this guy, all he would have is a handler that all it does is redirects to the secure version. You can find, there's examples online of people who've done that with Go. You can look for that to see how to do that, but that's a pretty common pattern. The other thing I want to mention is, yesterday I talked about Cloudflare. They did something cool recently, and that's that they now provide SSL support for free for anybody. So if you sign up for them and set your name server for your domain to them, they have a button which allows you to use your own self-signed security certificate, the one I just generated. So remember as a proxy, I talked about a proxy. So we have over here browser, right? So this is the browser. And that's connecting to your server. Right? So the idea of Cloudflare is they're in the middle. So now they connect to there, and now they connect to there. Okay? So they're in the middle between the two. And so they allow this to be the self-sign. The one with the big red, lock. So I'll draw it because I can. Right? So you get the red lock over here. And then over here, they're communicating with their server. So this is the Cloudflare server. Okay? And then your users see the green line. Okay? So you get the best of both worlds. You don't have to pay any money to these crazy providers who charge to get their authority trusted. You just use your own cert and it works. Because Cloudflare's like, sure, I'll allow traffic with that. I don't mind. And then over here, your users see the nice, great green lock icon. And everything's great. So that's a really cool service they provide because that means you don't have to spend money on getting your certificates. Okay? Everybody following?
Sorry, what? How is it just, it's just in place of a certificate you're saying, right?
They act as a proxy. They're a proxy. They sit, all the traffic that goes to your website will now go through Cloudflare in this model, if you sign up for Cloudflare.
Doesn't that undermine the security of the sign?
Yes, kind of. It's as if you've handed over responsibility of your site to Cloudflare, and then so this is secure. It hasn't undermined it because they are the users are confirming that it goes to Cloudflare. So that is confirmed. It went to what they said it did. But this piece the user doesn't know about. They don't know that there's this other server back there that it's doing this other stuff. Okay? But yeah, it does kind of undermine it.
Did that one cost money though?
Cloudflare's free. So there's no downside to this. It's all upside if you use this model. Okay. Cloudflare does other things which are great too. They do like caching and they do CDN services and all kinds of great stuff that make your site go faster. They also detect denial of service attacks and they prevent that kind of traffic. If your site goes down, they show a page that says, oh, the site's down, blah, 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 blah.
You recommend this over the SDL?
SDL.
Or the certificate,
Yes.
what's it called, the free one, SDL?
Yeah, so if you use the free one, it can get you the green icon. But I say, who cares? Use Cloudflare, which you probably wouldn't use anyway, because you want the CDN features, and just use your own server. So you don't have to do anything. See, because the problem with the one at the Start SSL, you have to make one for every single domain. So Google.com is different from www.google.com. That's a different domain name. So you need two certs for that. Because there is what's called a wildcard cert, which would be star.google.com. But they don't provide that kind of cert. They only provide the regular cert. So you'd have to make like lots of certs if you have lots of domains. So this way you don't have to do that.
Does Google have to provide any of this?
I haven't looked too far into it, but they do the custom domains, so probably, yeah, they'll handle it there if you have it that way. But yeah, so that's TLS in a nutshell. Because of the App Engine thing, we may not have to create TLS servers, we'll just create regular servers, and then Google will do the secure bit for us. But if you need to go, that's how we do it. So if none of this made any sense and you don't feel like trying to understand it, just watch it when you need to. Come back and it'll all make sense then. Well, it won't make sense, but you'll be able to figure it out. It's a chore. It's a real chore to do all this. Okay. So the final thing, which we'll do today and probably continue tomorrow, is a project. And so this is one of the things where like we can talk about learning this stuff and you can like do examples, but until you actually try to do it all together, it doesn't necessarily click, okay? And so it's a good idea to try and do it all together, and we know enough now to be able to make a simple website. The part we're missing are services, we're missing database and stuff, but there's a lot of websites that don't have databases. And we have at our disposal something which we've already used, like a database, which is our file system. We can save files. And so this project is to create a photo blog. And the photo blog is going to have several pages. So there'll be one page which lists all the photos. So we'll call this the first page. And it's going to have, like Tumblr or something, right? You have just a list of photos, right? Maybe the most recent on top. That's probably right, what a blog would do. And maybe only show 5, or whatever, however you want to do it. That's the idea. We're going to show a page, and there will be photos on it. Okay? The second page is an admin page. So this is if I go to localhost / okay? And this is if I go to localhost / admin. It'll go to this page, which will have a form with a little button, and in here is going to be a file, right? So, you know, it's got the browse button or whatever. And you click that, and then you click upload or submit, right? And then it's going to add that to this list. How's it going to do that? This list is generated from a directory. Right? So we'll read a directory of photos, and this is going to add a file to that directory. Okay? That's the idea. And then I put other things in here. So in order to implement this, we have to have a login page to get to the admin, because you don't want just anybody on the internet to be able to log in, right? So you're going to have a login page. So this is maybe 2, 3 might be the login page, which is going to have username, password, okay, right, so and then okay, or login, whatever you call it. And so that's the third page, and then the fourth page isn't really a page at all, it's just log out. So you can put that button on this page or something like that, but it needs to be able to log out. And so this should be a pretty easy, website to build. I put a few things to note in there. So the log out, log in, remember that. You can hard code the password, that's fine. You don't have to use a database. You need to use TLS. Okay? Because it has a login. So you have to have TLS. And then try to use HTML, CSS skills you learned earlier. So you can make it look like this. Please make it look better than this. So I said, feel free to team up. That makes some of this easier. And at the end, probably not today, but tomorrow, we will demo it. So you guys will be able to show what you built up here. And we'll see. Okay? And then we're going to have, and then you can explain your code. So you're going to basically do what's called a code review, which is very common practice in programming. And so everybody understand? Any questions about the project? It's a pretty open-ended. The other note I put at the bottom, it's intentionally open-ended. Using Google is not cheating. There is no cheating to this, okay? The point is that web development's not like a class where there's a test or something. It's if you can make it, you can make it, okay? So everybody understand?
Yeah.
Okay, perfect.